In this lecture, we will find the radius of the small circle. In the drawing, we have a square. One side of a square is equal to 8 units, and inside this square we have two circles. The radius of the big circle equals to 2r, and the radius of the small circle equals to r, and we want to find out the size of the radius or the value of the radius of the small circle. Okay, so first of all I will present to you two rules. The first rule is that a tangent to a circle is perpendicular to the radius drawn to its points to its point of tangency. So I will read rule number one again. Rule number one states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number one? The meaning of rule number one is that if we have a circle and the center of this circle is at point O, and we have tangent to the circle AB is tangent to this circle at point M. Let's define the center of the circle as point O. So the tangent AB is tangent to the circle at point M. Then actually this radius that is drawn to the point of tangency, that is to say to point M. So actually the tangent AB is perpendicular to this radius that is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. Therefore this tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees. This angle equals to 90 degrees, and this angle also equals to 90 degrees. So any radius like this radius that is drawn to the point of tangency, that is to say point M, then the tangent, that is tangent AB, that is tangent to the circle at point M, is perpendicular to this radius that is drawn to the point of tangency. So this angle equals to 90 degrees, and this angle also equal to 90 degrees. Again, whenever you have radius that is drawn to the point of tangency, like this example, that this radius is drawn to point M, then the tangent AB will be perpendicular to this radius, that is to say this angle is equal to 90 degrees, and this angle also equals to 90 degrees. Okay? And we also have rule number 2. Actually, rule number 2 says that if from one external point two tangents are drawn to a circle, then their lengths are equal to each other. Their lengths are equal, or they have equal lengths. So I will read rule number 2 again. Rule number 2 states that if from one point, or if from one external point, two tangents are drawn to a circle, then they have equal lengths. So what is the meaning of rule number 2? Rule number 2 states that if you have a circle, that could be any circle, and we have, for example, this point P, that is, this point P is external point to this circle, and if from point P you draw two tangents to this circle, that is to say, this is the first tangent. Let's define the point of tangency, or the touching point between the tangent to the circle is point A, and we have another tangent from the same point P to the circle. Let's define the touching point between the tangent to the circle as point B. So if from the external point P we draw two tangents to this circle, then the lengths of these two tangents are equal to each other. That is to say, AP equals to PB. Okay? So whenever you draw from external point two tangents to a circle, then the lengths of those two tangents will be equal to each other. So in this example, tangent PA equals to tangent PB in its lengths. The lengths of those two tangents are equal to each other. That is to say, AP equals to PB. Okay? So let's define the center of the small circle as point P, and we will define the center of the big circle as point Q, and then we will define the touching point between tangent AB to the small circle as point M, and we will draw radius from point P to point M. So here we can see that the point of tangency of tangent AB is at point M, and we have this radius that is drawn to the point of tangency, that is to say, it is drawn to point M. Therefore, this tangent AB will be perpendicular to this radius, that is to say, this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle that equals to 90 degrees. Okay? Again, whenever you have a radius like this example that is drawn to the point of tangency, and the point of tangency in this example is point M, we have this radius that is drawn to the point of tangency, then the tangent AB is perpendicular to this radius, that is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. Okay, so we will also draw, we'll define the touching point between, let's say, tangent AE to the small circle as point D, and we will join together points P and D. So PD will be the radius of the circle. So from point P, that is the center of this circle, we draw a line segment that touches the circle at point D. Therefore, it is defined as the radius of the small circle, that is to say, it equals to small r. So again, we have the point of tangency. Actually, the point of tangency here is at point D. Actually, tangent AE is tangent to the circle at point D, therefore the point of tangency here is point D, and we have this radius that is drawn to the point of tangency, that is to say, to point D. Therefore, the tangent AE is perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? And the same thing is true about this radius. Let's define the touching point between tangent BC to the small circle as point L, and again we have this radius that is drawn to the point of tangency, that is to say to point L. Therefore the tangent BC will be perpendicular to this radius that is drawn to the point of tangency. Therefore this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And the same thing is true about this radius of the big circle. Actually, the tangent AD is tangent to the big circle at this point. Let's define this point as point S. So we have here this radius that is drawn to the point of tangency, that is to say to point S. Therefore, the tangent AD is perpendicular to this radius that is drawn to the point of tangency. That is to say, this angle equals to 90 degrees. And this angle also equals to 90 degrees. Okay? And let's define the touching point between tangent DC to the big circle as point N, and we will connect points Q and N by a straight line. This straight line will be defined as the radius of the big circle. It equals to 2r because it exits from the center of the circle and touches the circle at point N. Therefore, Qn is the radius of the big circle, and this radius of the big circle is drawn to the point of tangency, that is to say it is drawn to point A, to point N, that is the point of tangency. Therefore, according to rule number 1, the tangent DC, this tangent, is perpendicular to this radius that is drawn to the point of tangency, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? And we know that all the four angles of a square are equal to 90 degrees, so angle ABC is one of the angles of square ABCD, therefore it equals to 90 degrees. And so in this small quadrilateral PLMB, we have three angles that equals to 90 degrees. So the sum of three right angles is 90 times 3, it is 270 degrees. Okay, we have three angles in quadrilateral PLMB. That in total are equal to 270 degrees. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, any quadrilateral has four angles, so, and we know that the sum of the three angles is equal to 270 degrees. Therefore, the fourth angle must be equal to 90 degrees, in order to complete the sum of the four angles to 360 degrees. So actually this angle is a right angle, it equals to 90 degrees, and in this way we actually complete the sum of the four angles to 360 degrees. And we know that any quadrilateral that has four right angles, it must be at least rectangle. Okay, so PLMB, quadrilateral PLMB, is a rectangle, and we know that the opposite sides of any rectangle are equal to each other. That is to say, MB equals to PL and PM equals to BL. Okay, so PL equals to MB, but we know that PM is the radius of the small circle, and PL equals to MB, so MB will be also equal to the radius of the small circle. And we also know that PM equals to LB, that is two opposite sides that are equal to each other in the rectangle. PM equals to LB, but PM equals to R, so LB will be also equal to R. Okay? So here we have quadrilateral rectangle with four sides that are equal to each other. So actually this rectangle is actually not rectangle but square. So actually quadrilateral PLMB is a square that has four equal sides, and the same thing is true also in this quadrilateral, in quadrilateral DNSQ. We know that the size of any angle of a square is 90 degrees, so this angle ADC is a right angle, it equals to 90 degrees. So in quadrilateral DNSQ we have three right angles that in total are equal to 270 degrees. So the fourth angle, and we know that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the fourth angle must be equal to 90 degrees in order to complete the sum of the angles in quadrilateral DNSQ to 360 degrees, because 90 times 4 is 360 degrees. Okay, and again, any quadrilateral that has four right angles like quadrilateral DNSQ must be at least must be a rectangle, and we know that the opposite sides of a rectangle are equal to each other, so NQ equals to SD, but NQ equals to 2R, so NQ that equals to SD will be also equal to NQ equals to SD, so SD that equals to NQ must be also equal to 2R. And in the same way, we know that the opposite sides in rectangle DNSQ are equal to each other, that is to say SQ equals to DN, and SQ equals to 2R, so DN must be also equal to 2R, according to the rule that the opposite sides in any rectangle are equal to each other. So actually we found out that this shape quadrilateral DNSQ has four right angles and four sides that are equal to each other. So actually the shape of quadrilateral DNSQ is not a rectangle but a square. Okay? So, and actually here, what is the size of AS? The size of AS or SA equals to the size of AD minus the size of SD. Again, AD minus SD equals to AS. But AD equals to 8 units and SD equals to 2R. So the size of AS is AD, that is 8, minus SD, that is 2R. That is to say SA or AS equals to 8 minus 2R. And what is the size of AM? The size of AM, it is actually AB minus MB. AB minus MB equals to AM, but AB equals to 8 units, and MB equals to R. So the size of AM is actually AB, that is 8 units, minus MB, that is R. That is to say AM equals to 8 minus R. Okay, so in the next step, we will join together points P and A by a straight line. And we will prove that the right triangle AMP, this right triangle is congruent to the right triangle ADP. Okay, so we will focus on the right triangle AMP and the right triangle ADP. And we will prove that those two right triangles can go into each other. The right triangle AMP can go into the right triangle ADP. Okay? Those two right triangles can go into each other. First of all, we know that AM equals to AD. Again, AM equals to AD according to rule number 2, that states that if from external point of the small circle we draw two tangents to the small circle, then the lengths of those two tangents are equal to each other. That is to say, AM equals to AD. That is according to rule number 2, AM equals to AD. And we also know that PM equals to PD equals to the radius of the circle. PM equals to PD equals to the radius of the small circle. Okay. And AP is a common side. It belongs to both triangles. So we can write down that AP equals to AP. It's a common side. Again, AP equals to AP is a common side that belongs to both triangles. So we actually proved that the three sides of the right triangle AMP are corresponding equal to the three sides of triangle ADP. Therefore, those two right triangles can go into each other according to side rule. So I will write it down. Triangle AMP is congruent. This is the sign of congruent to triangle ADP, the right triangle ADP, according to side rule. Okay, so what is side rule? Side rule is that if you prove that three sides of one triangle are correspondingly equal to three sides of the other triangle, then you proved that those two triangles can go into each other according to side rule. And we proved that those two right triangles can go into each other according to side rule, because we have this side that equals to this side equals to this side, and this is a common side. So we proved that three sides of the right triangle APM are correspondingly equal to three sides of the right triangle APD. Therefore, those two right triangles can go into each other according to side rule. And from the fact that those two right triangles can go into each other, we will conclude that those two angles are equal to each other. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other. Therefore, those two corresponding angles will be equal to each other. So we can write down that angle MAP, this angle, is equals to angle DAP, this angle. Again, according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define this angle as alpha, then this angle will be also equal to alpha because of the fact that those two angles are equal to each other. Okay? So we found out that angle MAP equals to angle DAP, and both those two angles are equal to alpha according to our definition. Okay? In the next step we will do a construction. We will join together points A and Q by straight line. And we will join together. First of all, we will define the touching point between tangent AE to the big circle as point G, and we will join together points Q and G by a straight line. So as you can see, line segment QG exits from the center of the big circle and touches the big circle at point G. Therefore, QG is the radius of the big circle that equals to 2R. Okay, and again, we have the point of tangency that is point G, and we have the radius QG that is drawn to the point of tangency that is point G. Therefore, the tangent AE is perpendicular to this radius at the point of tangency. That is to say, this angle is equal to 90 degrees, and this angle also equals to 90 degrees. Okay? So in the next step, we will prove that those two right triangles can go into each other. Actually, that the right triangle, triangle AGQ, can go into the right triangle, triangle ASQ. So I will write it down. We will prove that the right triangle, triangle AGQ, this right triangle, is congruent to the right triangle triangle ASQ. Again, we will prove that those two right triangles can go into each other. Okay? That the right triangle AGQ can go into the right triangle ASQ. Okay? So first of all, we know that AQ equals to AS. AQ, it is actually AG. This is G, letter G, so AG is congruent to AS according to rule number 2. AG, side AG congruent to side AS according to rule number 2. Actually, here we have an external point, that is to say point A is external point to the big circle, and from the external point A we drew two tangents to the big circle, tangent AD and tangent AS. Therefore, according to rule number 2, the length of those two tangents that are drawn from external point A are equal to each other. That is to say, AG equals to AS, according to rule number 2. And we also know that QG equals to QS equals to the radius of the big circle. QG equals to QS equals to the radius of the big circle. QG equals to QS equals to the radius of the big circle, that is actually 2R, according to what is given us in the question. And we also have a common side. AQ is a common side, it belongs to both triangles, so we can write down that AQ equals to AQ. It's a common side that belongs to both triangles. Again, AQ equals to AQ is a common side that belongs to both triangles. So again, we proved that three sides of the right triangle AGQ are corresponding equal to three sides of the right triangle ASQ. Therefore, we proved that those two right triangles can go into each other according to side rule. So I will write it down. We actually proved that the right triangle AGQ is congruent. Again, this is the sign of congruent to the right triangle ASQ according to side rule. Okay, I have already explained you what is side rule. Okay, so from the fact that those two right triangles can go into each other, we will conclude that those two angles are equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other, therefore those two corresponding angles will be equal to each other. That is to say, angle GAQ, or angle QAG is equal to angle SAQ. Angle QAG is equal to angle SAQ according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define this angle as beta, then this angle will be also equal to beta. So we actually found out that angle QAG is equal to angle SAQ, and both angles are equal to beta according to our definition. Okay, so actually we know that angle BAD is one of the four angles of square ABCD. Therefore, it must be equal to 90 degrees because of the fact that all the angles of a square are equal to 90 degrees. Therefore, angle BAD equals to 90 degrees. But angle BAD consists of four angles. So actually, we can write down that alpha plus beta equals to the size of angle BAD, that equals to 90 degrees. So we can write down that the first equation, that 2 alpha plus 2 beta is equal to 90 degrees. This is equation number 1 that states that 2 alpha plus 2 beta equals to 90 degrees. Here we'll divide this equation number 1 by 2, and we will get that alpha plus beta equals to 90 degrees over 2 is 45 degrees. So we actually found out that alpha plus beta equals to 45 degrees. Okay, alpha plus beta equals to 45 degrees. But we know that if alpha plus beta is equal to 45 degrees, then tangents alpha plus beta will be equal to tangents 45 degrees. Very simple. If alpha plus beta equals to 45 degrees, then tangents alpha plus beta will be equal to tangents 45 degrees. Okay? So the question number 2 will be that tangents alpha plus beta equals to tangents 45 degrees. Okay? So tangents alpha plus beta equals to tangents 45 degrees is 1, so we got that tangents alpha plus beta equals to 1. Okay? But we actually have trigonometric identity for the value of tangents alpha plus beta. According to the following trigonometric identity, the value of tangents alpha plus beta, it is actually equals to tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta. Okay? Again, tangents alpha plus beta equals to tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta. Okay? So actually, according to this trigonometric identity, we can substitute tangents alpha plus beta by this expression, because this expression equals to tangents alpha plus beta. So we will do it. So equation number 1 will be that tangents alpha plus beta, it is according to the trigonometric identity, tangents alpha plus beta equals to tangents alpha times tangent plus tangents beta over 1 minus tangent alpha times tangent beta. All equals to 1, so again we have this equation number 1 that states that tangent alpha plus beta equals to 1. But we have this trigonometric identity that tangent alpha equals to this expression, so we can substitute the tangent alpha plus beta in equation number 1 by this expression. So here in equation number 1 we substituted tangent alpha plus beta by this expression that equals to tangent alpha plus beta according to the trigonometric identity that I presented to you. So here we will find out the value of tangent alpha and tangent beta according to the drawing. So here we have the right triangle, triangle AMP. So in the right triangle, this right triangle, triangle AMP, we know that tangent alpha is actually the relationship between the angle that is the relationship between the side that is in front of the angle over the side that is near the angle. That is to say, it equals to PM over AM. Again, tangent alpha equals to PM over AM. Okay, actually tangent alpha equals to PM over AM, but we know that PM equals to R, that is the radius of the small circle, and AM equals to 8 minus R. We have already found out that AM equals to 8 minus R. So in total we got that tangent alpha actually equals to R over 8 minus R. So we found out the value of tangent alpha. Tangent alpha equals to R over 8 minus R. And what is the value of tangent beta? If we focus on the right triangle, triangle ASG, in the right triangle, triangle ASG, tangent beta will be equal to SQ over SA. SQ over SA. Again, tangent beta will be equal to SQ over SA. But SQ equals to 2R, as you can see from the drawing. SQ equals to 2R. And we've already found out that SA equals to 8 minus 2R. So in total we got that tangent beta equals to 2R over 8 minus 2R. So we actually found out the values of tangent alpha and the value of tangent beta, so we can substitute tangent alpha and tangent beta in equation number 1 by the values that we found here for tangent alpha and tangent beta. So we will do it now. So actually, according to equation number 1, tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta equals to 1. So what is the value of tangents alpha? Tangents alpha equals to r over 8 minus r plus tangents beta. What is the value of tangents beta? The value of tangents beta is 2r over 8 minus 2r. And we must divide all by 1 minus tangents alpha, that is actually r over 8 minus r times 2r over 8 minus 2r. So, and all equals to 1. So we actually substituted tangents alpha and tangents beta by their values that we found here, and we got this equation number 1. This expression that is actually, we have here one equation with only one variable that is very simple to solve. So here we will take a common factor for these two expressions in the numerator of this expression, and we will get that here we have question number 1 that in the denominator we will have 8 minus r times 8 minus 2r, and so here we have r minus 8 minus r, so it will be r times 8 minus 2r. Okay, so this expression, it is actually r over 8 minus r plus 2r over 8 minus r, so it will be 2r times 8 minus r, and this expression is equals to 2r over 8 minus 2r. Okay, this expression equals to 2r over 8 minus 2r. Okay, and all divided by 1 over r times 2r is 2r squared over 8 minus r times 8 minus 2r, all equals to 1. So actually here we have 8 minus r times 8 minus 2r, and we have 8 minus r times 8 minus 2r. So if we move this expression to the numerator, then this expression will get cancelled with this expression, so we can cancel it right now. This expression will get cancelled with this expression. So what is left after we cancelled this expression? What is left is actually that here we will open the brackets. R times 8 is 8r plus minus 2r squared plus, we will open the brackets, it is 16r minus 2r squared, all divided by the numerator, that is actually 1 minus 2r squared, and all equals to 1. So actually that is what is left after we cancel the two expressions. Here we will cross multiply, or we will multiply this equation by 1 minus 2r squared. We will get that here we have here it is actually 8r. So 8r plus 16r is 24r, and minus 2r squared is minus 4r squared. It equals to 1 minus 2r squared. Okay. So here we will add to this equality 4r squared, and we will get that 2r equals to 4r squared minus 2r squared is 2r squared plus 1 we will subtract from this equality 2r, and we will get that we have the quadratic equation that 2r squared minus 2r plus 1 equals to 0. Actually we have the general formula for a quadratic equation. So actually here, before we cancelled those two expressions, actually we will take a common factor, or we will substitute r by 8 minus r over 8 minus r times 8 minus 2r over 8 minus 2r. Okay. So we get that r over 8 minus r plus 2r Here we will substitute 1 by 8 minus r over 8 minus r times 8 minus 2r over 8 minus 2r. So we substitute at 1 by this expression that equals to r, and here we have to subtract minus 2r squared, and all will be equal to 1. So we got this equation number 1. So here we have 8 minus r times 8 minus 2r and 8 minus r over 8 minus 2r. After we will move this expression to the numerator, it will get cancelled with this expression in the numerator, so we will cancel it right now. And what is left after we cancelled this expression? So actually, this is what is left after we cancel those two expressions. Here we will cross multiply this expression, and we will get that r times 8 minus 2r plus 2r 8 minus r equals to 8 minus r times 8 minus 2r minus 2r squared. So here we will open the brackets in equation number 1 from two sides of the equation, and we will get that r times 8 is 8r, r times minus 2r is minus 2r squared, plus 2r times 8 is 16r, 2r times minus r is minus 2r squared, and it equals to 8 times 8 is 64, 8 times minus 2r is minus 16r, minus r times 8 is minus 8r, and minus r times minus 2r is plus 2r squared, minus 2r squared. So here we have minus 2r squared plus 2r squared minus 2r squared, it is 0. So this 2r squared minus 2r squared equals to 0. So what is left after we cancel this expression? is actually 8r plus 16r is 24r. Minus 2r square minus 2r square is minus 4r square equals to 64 minus 16r minus 8r is minus 24r. So here we will subtract from equation number 1 24r, and we will get that minus 4r squared equals to minus 48r plus 64. So we will add to equation number 1 4r squared, and we will get that 4r squared minus 48r plus 64 equals to 0. Here we will divide this equation number 1 by 4, and we will get that r squared minus 12r plus 16 equals to 0. So this is our quadratic equation. So, and we have the general formula for a quadratic equation is that ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula that x equals to minus b plus minus root of v squared minus 4 times a times c over 2a. Again, a, b, and c in this formula are the coefficients of this quadratic equation, and x is the variable that we are looking for. And in our specific quadratic equation, x equals to r. R is the variable that we are looking for, and we know that a equals to 1, b equals to minus 13, minus 12, b equals to minus 12, and c equals to 16. So all we have to do is to put the data inside this equation in order to find out the root of r. So according to this quadratic equation, r equals to minus b, b equals to minus 12, so minus minus 12 is plus 12, plus minus root of b squared minus b equals to 12, so 12 squared minus 12 squared is 144, minus 4 times a is 1, 4 times 1 is 4, and 4 times 16 is 64, so all divided by to 8, that is 2 times 1 is 2, and then we have, so r equals to 12 plus minus root of 144 minus 64 is 80, 80 over 2. Okay, so here 80 equals to 20 times 4, so we write it down. R equals to 12 plus minus root of 80 is 20 times 4, 4 times 20 over 2. Okay, so here we have R equals to 12 plus minus, actually root 4 is 2, so we have 2 times root 20, square root of 20 over 2. So R equals to 12 over 2 is 6, 2 over 2 is 1, so in total we got here 6 plus minus root of 20. 20 equals to 4 times 5, so we write it down that R equals to 6 plus minus root of 4 times 5. So actually R equals to 6 plus minus root of 4 is 2. So in the root, inside the root we have only 5. So we have here two answers, two possibilities. Either R equals to either 6 plus 2 times root 5, or R also could be equal to 6 minus 2 times root 5. Okay? So we have those two options, but we also know that AB equals to 8 units. AB equals to 8 units. AB equals to 8 units, but, and also, we also see from the drawing that the radius is inside this, the square, because of the fact that both the big circle and the small circle is inside the square. That is to say, the radius of the small circle, that is R, must be less than 8 units. Because of the fact that R is less than 8 units, and actually R that equals to 6 plus 2 times R that equals to 6 plus 2 times root 5 is greater than 8, and R must be less than 8 units, so this answer is not correct, and we left only with the answer that R equals to 6 minus 2 times root 5. So the radius of the small circle is R equals to 6 minus 2 times root 5 units, or actually it equals more or less to 1.53 units. Okay, I will repeat again. The answer to the question is that the radius of this small circle equals to either 6 minus 2 times root 5 units, or in terms of numbers, the radius of the small circle is more or less equal to 1.53 square units. Okay? So now I'll summarize the lecture. Actually, we wanted to find out the radius of this small circle, and we have in the drawing a square, and in this square we have two circles. The big circle has radius that equals to 2r, and the small circle has radius that equals to r, and we want to find out the radius of this small circle. So actually, in order to find out the radius of the small circle, I presented to you two rules. Rule number one states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So actually, rule number one means that if you have tangent AB that is tangent to this circle at point M, and you have this radius that is drawn to the point of tangency, that is to say, this radius is drawn to point M, that is the point of tangency. Therefore, according to rule number one, this tangent AB, is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So, whenever you have radius that is drawn to the point of tangency, that is to say point M, like in this drawing, then the tangent will be perpendicular to this radius. This angle is 90 degrees and this angle is 90 degrees. So this is rule number one, and we also have rule number two. Rule number two states that if from one external point two tangents are drawn to a circle, then they have equal lengths. I will repeat again on rule number two. Rule number two states if from one external point two tangents are drawn to a circle, then they have equal lengths. So what is the meaning of rule number four? Rule number two. Rule number two states that if from external point, that is to say, point P is an external point to this circle, and from point P you draw two tangents to this circle, that is to say tangent PA and tangent PB, then the lengths of those two tangents are equal to each other. That is to say, PB equals to PA. So whenever you draw from one external point, two tangents to a circle, then the lengths of those two circles, the lengths of those two tangents will be equal to each other, like in this drawing, that AP equals to PB. Okay? So that is the meaning of rule number two. And then we actually defined the center of the small circle as point P. We defined the center of the big circle as point Q. And we note that we join together points A and P by a straight line. We drew those two radiuses. So according to rule number one, this radius that is drawn to the point of tangency, that is to say point M. Because of this fact, the tangent AB is perpendicular to this radius, that is to say this angle is 90 degrees and this angle is 90 degrees. The same thing is true for this radius that is drawn to the point of tangency, that is to say to point L. Therefore, this tangent is perpendicular to this radius, that is to say this angle is 90 degrees and this angle is 90 degrees. Then we also join points P and D together by a straight line. And again we have line segment AE that is tangent to the small circle at point D. And we have this radius that is drawn to the point of tangency, that is to say point D. Therefore, this tangent AE to the small circle is perpendicular to this radius, that is to say this angle is 90 degrees and this angle is also 90 degrees. Okay? So actually we know that the four angles of a square are equal to 90 degrees each of them. So this angle, that is angle ABC of the square, is equal to 90 degrees. We've already found out that this angle equals to 90 degrees and this angle equals to 90 degrees. So the sum of those three right angles is 3 times 90 is 270 degrees. And we know that the sum of the angles in any triangle is equals to 360 degrees. And we have already three angles that the sum of them is 270 degrees. So in order to complete the sum of the angles to 360 degrees in the quadrilateral PL and B, this quadrilateral, this angle MPL must be equal to 90 degrees. So we actually found out that in this quadrilateral we have four right angles. Therefore, it must be at least rectangle, because any quadrilateral that has four right angles, it must be at least rectangle, if not a square. So this shape PMBL, if it is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say PM equals to LB and PL equals to MB. So PM equals to LB, but we know that PM equals to R, so LB will be also equal to R because of the fact that those two sides are equal to each other. And we also know that PL equals to R and PL equals to MB because of the fact that the opposite sides of a rectangle are equal to each other. And if PL equals to R, then PL that equals to MB will, so because of the fact that PL equals to MB, then MB will be also equal to R. So we actually found out that the shape PLMB has four right angles and all of its sides are equal to each other, so this shape is a square. Okay, it is a square. And what is the size of AM? AM it is actually equals to AB minus MB. So AB is 8 units and MB is R. So actually AM equals to 8 minus R. And then we calculated, and we also did the same thing here. This angle equals to 90 degrees because it's one of the square's angles. All of them are right angles, so this angle equals to 90 degrees. Again, this angle is a right angle because of the fact that this radius is drawn to the point of tangency, that is to say to point S. Therefore, the tangent DA is perpendicular to this radius that is drawn to the point of tangency, that is to say this angle is 90 degrees and this angle is 90 degrees. And the same thing is also here. We have tangent DC that is tangent to this circle at point N. Therefore, and we have the radius that is drawn to the point of tangency, that is to say to point N. Therefore, this tangent is perpendicular to this radius, that is to say this angle is 90 degrees and this angle is 90 degrees. So we actually have here 3 right angles, and the sum of 3 right angles is 270 degrees. And we know that the sum of the angles in any quadrilateral is 360 degrees, so we have already 270 degrees. So the fourth angle, this fourth angle must be equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees. So this is also a right angle, so we have 4 right angles, and any quadrilateral that has 4 right angles, it must be a rectangle, at least a rectangle. So and we know that the opposite sides of a rectangle are equal to each other, so SQ equals to DN, and we know that SQ equals to 2R, so SQ, so DN that equals to SQ will be also equal to 2R because they are equal to each other. And we also know that side QN must be equal to side SD, because in triangle the opposite sides are equal to each other. But we know that QN equals to 2R, so SD that equals to QN must be also equal to 2R. So we found out that shape, the quadrilateral DN SQ is a square. Okay, so here what is the size of SA? SA equals to AD minus SD, that is to say it equals to 8 minus 2R, and we already found out the value of AM, it is 8 minus R. So actually we proved that those two right triangles can go into each other because of the fact that AM equals to AD. According to rule number 2, if from external point A we draw 2 tangents to the small circle, then the lengths of those 2 tangents are equal to each other, that is to say AM equals to AD according to rule number 2, and also PM equals to PD equals to the radius of this circle, and we have AP that is a common side, so AP equals to AP is a common side. So we found out that the right triangle AMP is congruent to the right triangle ADP according to side rule, and from that fact we concluded that those 2 angles are equal to each other, and if one of them is alpha, then the other one will be also equal to alpha. Okay, and again MAP equals to angle DAP equals to alpha according to our definition. Then we join together points A and Q by a straight line, and we proved that those 2 right triangles can go into each other. Actually, we know that AG equals to AS according to rule number 2. From this point, external point to the big circle, we drew 2 tangents to this circle, so they are equal in their length. So that is to say AG equals to AS according to rule number 2. And we have here QG that equals to SQ equals to 2R. And we have a common side, AQ equals to AQ. It is a common side that belongs to both triangles. We actually prove that those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. And if this angle is beta, then this angle will be also equal to beta. And we know that, so actually angle QAG equals to angle SAQ equals to beta according to our definition. And we know that angle BAD is the right angle because it is one of the angles of square ABCDs. All the angles of square ABCD are equal to 90 degrees, so this angle equals to 90 degrees, but this angle equals to 4 angles, 2 alpha and 2 beta. So we can write down that 2 alpha plus 2 beta equals to 90 degrees. 2 alpha plus 2 beta equals to 90 degrees. We will divide this equality by 2 and we will get that alpha plus beta equals to 45 degrees. But if alpha plus beta equals to 45 degrees, then tangent alpha plus beta will be equal to tangent 45 degrees. Tangent alpha plus beta is 1, and the tangent alpha plus beta, we have a trigonometric identity from tangent alpha plus beta. According to this trigonometric identity, tangent alpha plus beta equals to tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Okay, so we can substitute tangent alpha plus beta by this expression. We did it and we got that this expression is actually tangent alpha plus beta, and it equals to 1. And we calculated the values of tangent alpha and tangent beta according to the drawing. According to the drawing, tangent alpha equals to PM over AM, that is to say it equals to R over 8 minus R. Tangent alpha equals to R over 8 minus R, and tangent beta in this right triangle, tangent beta equals to, in this right triangle, tangent beta equals to SQ over SA. That is to say tangent beta equals to 2R over 8 minus 2R. Tangent beta equals to 2R over 8 minus 2R. So actually we substituted tangent alpha and tangent beta in equation number 1 by their values that we found here, and we got this equation number 1. It is one equation. We found variable that is R. We solved this equation and we got two answers. Actually, the first answer is that the radius equals to 6 plus 2 times root 5, and the second answer that the radius of the small circle equals to 6 minus 2 times root 5. But we know that AB equals to 8 units. AB is the side of one side of the square, and the small square is inside the square. So the radius of this small square must be less than the size of the square, because the circle is located inside the square. So its radius must be less than the size of the square, that is 8 units. So actually R must be less than 8 units, but here R equals to 6 plus 2 times root 5 is greater than 8 units, therefore this answer is not possible, is not correct answer, and we left only with the answer that the radius of the circle is equal to 6 minus 2 times root 5, that is actually equals to 1.53 units. So the radius of this small circle equals to either 6 minus 2 times root 5 units, or in terms of numbers, if the radius of this small circle equals to 1.53 units. Okay, thank you very much.